Hello and welcome to another Physical Sciences 3 lecture. Today we're looking at electrical power. And the good news is you know a fair bit about electrical power already. So because electrical power is very similar to mechanical power. So I'm going to change the color of my pen. Let's go back to blue. Okay, so we have power here is the same as it is the change in energy over time. Okay, then we have these other four ones which relate a few of our quantities. So we have voltage is equal to change in energy over charge. The current here is equal to the charge over time. And V is equal to I times R. Okay, so they are all equations that we've seen recently. And if you substitute these four different equations into each other and rearrange them, then you can get these three different cases where we have P equals VI, P equals I squared times R, and P is equal to V squared over R. So that's voltage, current, and resistance. All right, and then we can use these ones here for finding the quantities. So for finding our power. This is just a note here to say it's a really useful algebraic exercise to derive each of the three cases from the four equations which we've seen previously in the course, but we're not going to show each one of them. You can either find it out yourself or take our word for it. These are on the formula sheet and you'll have them in the exam at the end of the year. Okay, so it's just a matter of substituting in the values in these first couple of examples. So we have a car light globe has 12 volts across it, so that's V across it, and I 2.5 amps passing through it. At what rate is the globe dissipating energy? Well, P is equal to V times I. That's equal to 12 times by 2.5. And let's chuck that into our calculator. So we had 12 times 2.5 equal to 30. All right, equals to 30, and that's in watts, W. Okay, so a light globe rated at 60 watts is connected to the mains. What current will flow through the globe? So one of the things that we say is that mains are equal to 240 volts, so that helps. So we can use the equation above as well. So we have P equals VI. Then we have 60 watts is equal to 240 times I. So that means that I is going to be equal to 0.25 amps. So when we divide 60 by 240, then we get 0.25. What is the resistance of the globe? Okay, so let's go back up to our equations up here. We can use one of these ones up here. I'm going to use, let's see, because they've given us P and we've given us P and V to start off with, I'm going to use P is equal to V squared over R. P equals V squared over R. I mean, then you can use it. We can use it to check with our I if we like as well. We might do that as well. So P equals V squared over I. I'll fill these in. So let's go R is equal to V squared over P. So therefore R is equal to 240 squared divided by 60. So the resistance is going to be 240 to the power of 2 divided by 60. So 960 ohms. Okay, so that's one way we could have done it. Let's just look at another way we could have worked this out. We could have used P equals I squared, or P equals I squared R. Okay, so P equals I squared R. So R is equal to P divided by I squared, which means that 60 divided by 0.25 all squared. Oops. You can go back up there, thank you. Great. And that is equal to, chuck that into a calculator, let's see if that's the same. 60 divided by 0.25 squared is equal to 960. Great. 960. Okay, and ohms like that. So a couple of examples there of just rearranging the equations that we need. We'll look at the next examples next time.